course, and in this video we'll be looking at the oxides of nitrogen. Oxides of nitrogen. So oxides of nitrogen are binary compound of oxygen and nitrogen, and because nitrogen is a polyvalent element, it has variable valencies. It can react with oxygen with different oxidation states. So the 6 compounds that you have on your screen are the 6 different ways by which nitrogen can combine with oxygen. The first, we have nitrogen 1 oxide. The formula is N2O, where nitrogen is exhibiting an oxidation number of +1. A nitrogen 2 oxide NO, nitrogen there has oxidation state of +2. In dinitrogen 3 oxide N2O3, nitrogen is having a +3 oxidation state. In nitrogen 4 oxide NO2, we have nitrogen having an oxidation number of +4. In dinitrogen 4 oxide, this kind of configuration, you are going to have NO2 and N2O4. They are 2 different interconvertible compounds. That is, N2O can convert to N2O4 and vice versa based on suitable conditions. And in both cases, the nitrogen there they are exhibiting a +4 oxidation number. Then dinitrogen 5 oxide, we have nitrogen exhibiting a +5 oxidation state. You can be asked in your exam to state 4 oxides of nitrogen where nitrogen exhibits either +1 or +2 or +3, like that. Those are common questions, popular questions among exam bodies, to name compound of oxygen, to name oxides of nitrogen where the nitrogen inside is having a +1 oxidation state, a +2 state, +3 state, and on like that. So we want to look at the first oxide of nitrogen, the nitrogen 1 oxide. It was discovered by Joseph Priestley as the first oxide of nitrogen, and it was popularly known as laughing gas because it produced fits of laughter when you inhale it. It is normally produced by the thermal decomposition of ammonium triisonitrate 5, that's NH4NO3. When you decompose the compound, it normally give you water and N2O gas. So as you can see in the diagram, when you heat the compound, it gives you water and dinitrogen 1 oxide gas. But eating this compound directly is not advisable because the reaction is exothermic and can lead to explosion. So just like we produce nitrogen by mixing 2 salts together that will generate NH4NO2 that will give nitrogen, the same thing also we are going to do here. We are going to mix 2 compounds together that when you mix them together, it will give you NH4NO3. Upon decomposition, which will produce N2O and water. So what we normally use in this place is the potassium triisonitrate 5 KNO3 and ammonium chloride NH4Cl. So the NH4Cl will provide the NH4 and the KNO3 will provide the NO3. So the remaining 2 elements will pick themselves and form KCl. So now we have our NH4NO3, which can quickly decompose and give us water and N2O gas. Don't forget, the major difference between NH4NO3 and NH4NO2 in the decomposition is that NH4NO3 produces N2O, whereas NH4NO2 produces nitrogen gas N2. And this is the diagram for the setup, laboratory setup. You have to master this. So what you have is a mixture of potassium nitrate and ammonium chloride heated, right? Heated. So you collect the gas over warm water because the gas is fairly soluble in cold water. So want to look at the properties of N2O. N2 is a colorless gas with a pleasant smell. It has a sweetish taste. It's fairly soluble in cold water and is denser than air. So because it's soluble in cold water, you have to collect it over warm water. Denser than air means you collect it by downward delivery of the gas. So it is neutral to moist litmus paper. It does not burn in air, but can allow a brightly burning substance sufficient enough to decompose it into oxygen to continue burning. Substances like burning magnesium, burning phosphorus, burning carbon, red hot carbon can decompose N2O into oxygen and continue burning. However, if the compound is not burning with sufficient heat, it will not be able to decompose it. So we want to look at the chemical properties of nitrogen 2 oxide. Nitrogen 2 oxide rekindles a brightly glowing splint but extinguishes a faintly glowing one, which is not sufficiently producing heat that can decompose it to oxygen. So I've already mentioned that any brightly burning substance can decompose the N2O into oxide of that substance and nitrogen gas. Nitrogen 2 oxide can also be reduced by heated copper into nitrogen. Heated iron too can be used for that reaction. So as you can see now, because heated copper is a solid and N2O is a gas, you put the heated copper inside the combustion tube and you pass the nitrogen gas into it. So as the nitrogen 1 oxide gas rather enters into the combustion tube, it reacts with the copper turnings that must be heated continuously. It must be heated. So as it's being heated, so what happens is that it produces N2O gas, N2 gas, which is collected as gas P in this diagram. So basically it gets reduced by heated copper into nitrogen or gas. What are the uses, or what is the use of nitrogen 1 oxide? Because it has pleasant smell, it produces fits of laughter. Scientists have used it in the medical science as anesthetic for minor surgical operation. Thank you.